of limits given. Example 2. Evaluate integration from 0 to 1, then 0 to 1 minus x in bracket x plus y dx dy. Now again here outer limits are constant, that is 0 to 1. Inner limits are 0 to 1 minus x, that means inner limits are functions of x. Inner limits are functions of x. Therefore, first integrate with respect to y, taking x as a constant. Inner limits are functions of x. Therefore, first integrate with respect to y, taking x as a constant. Therefore, integration is outer limits 0 to 1. Now, first we have to integrate 0 to 1 minus x in bracket x plus y. First integrate with respect to y, therefore dy, and outside is dx. Now first we have to integrate with respect to y, therefore first is dy, x plus y is a term, and then outside is dx. Now first integrate taking x as a constant. Taking x constant. Now integration 0 to 1 in bracket integration of x plus y. How x plus y is integrated? Integration of x plus y dy means, now here x is constant, so here actually x should be outside, and integration of only dy and plus integration of y dy. X is constant, therefore x is outside. X integration of dy is xy, and integration of y is y square by 2. So first integration is integration of x dy means xy, plus integration of y is y square by 2, limit 0 to 1 minus x, and dx as it is. Now upper limit integration is with respect to y, therefore it is values of y. Upper limit of y is 1 minus x, and lower limit of y is 0. Integration 0 to 1 x into, at the place of y, upper limit 1 minus x, 1 minus x, plus y square. The value of y is 1 minus x, that is 1 minus x bracket square upon 2. This is upper limit minus lower limit. For upper limit we have to take one bracket minus lower limit. Y value is 0, x into 0 is 0, y square is, y is 0, so y square becomes 0. 0 upon 2 is also 0. And dx. Integration 0 to 1. Now first solve these terms. X into 1 is x minus x into x is x square plus 1 minus x bracket square upon 2. 1 minus x bracket square, that is 1 minus 2x plus x square by 2. And integration is with respect to x, that is dx. X minus x square plus 1 minus 2x plus x square upon 2. It is integration 0 to 1 x minus x square plus 1/2 minus 2x upon 2, means 2 cancel, that is minus x plus x square by 2 with respect to x. Means 2 is divided for each term. 1/2 minus 2x upon 2, that is 2 cancel, that is minus x, and x square by 2. This is plus x and minus x is cancel. Then 0 to 1. Remaining terms, x square by 2 minus x square and plus half dx. X square by 2 minus x square means addition of these same type terms. X square by 2 minus x square, that is LCM is 2, means x square minus 2x square, that is equal to x square minus 2x square means minus 1 minus 2 is minus 1, therefore minus x square by 2. 0 to 1 minus x square by 2 plus half dx. Now when the terms are only in x and the terms are separate, first we have to integrate now. With respect to x. Integration, minus is already here, minus integration of x square minus half, as it is integration of x square is x cube by 3 plus half x. Here we can take it easy way, minus 1/2 is outside, then integration from 0 to 1 minus x square plus 1 dx, and then integrate with respect to x. 1/2 minus x square, integration of x square is x cube by 3 plus 1 dx, integration of 1 dx is x. Limit is from 0 to 1. X is equal to 1 upper limit and x is equal to 0 lower limit. Is 1/2 value of x is 1, so minus 1 cube is 1, that is 1 by 3. Value of x is 1, that is plus 1, minus lower limit, x is equal to 0. Next value is also 0. Means 1/2 into 3 is LCM, minus 1 plus 3 upon 3, that is 1/2. 3 minus 1 is 2 upon 3, 2 to cancel, that is answer is 1/3. Now in first two examples, we have taken the examples when the inner limits are functions of x. Now we will take one example when inner limits are functions of y. Example 3, evaluate. Integration from 0 to 1, then integration from 0 to under root of 1/2 in bracket 1 minus y square dx dy upon under root of 1 minus x square minus y square. Now in this example, inner limits are functions of y. Inner limits are functions of y. Therefore, first integrate with respect to x, taking y constant. Outer limits are constant always, 0 to 1. First we have to integrate 0 to under root of 1 minus 1/2 into 1 minus y square. First integrate with respect to x. So 1 upon under root of 1 minus x square minus y square. Integrate with respect to x first, therefore dx, then bracket, and outside should be dy. Means first we have to integrate with respect to x, therefore first should be dx and outside of the bracket dy. Now we have to integrate taking y constant. At the time of integration, y is constant. Therefore y square will be also constant. Y square is also constant. Then we can say that 1 minus y square is also constant. Both these terms are constant, and therefore let 1 minus y square is equal to any constant a square. Now constant is taken as here a square because the neighboring term is in form of square. 1 minus y square will become a square, and this 1 minus y square will become a square minus x square. That means we can apply formula. Then first we are not integrating, we are just, this is not substitution, we are just taking 1 minus y square as a square. Limit 0 to under root of 1/2. 1 minus y square term is a square. Then 1 upon under root of 1 minus y square as a square. A square minus x square dx in bracket, then dy. This is not substitution, only we consider that 1 minus y square is a square. Then here integrate first term which is in bracket, integrate here with respect to x. Then integration is 0 to 1. Now for this term, formula is integration of 1 upon under root of a square minus x square dx is equal to sine inverse of x upon a. For this term, we use this formula. Integration is sine inverse x upon a, and limit is 0. Lower limit is 0. Upper limit is under root of half and a square. Root a square means a, and by 2, therefore it is under root, therefore a by root 2 and dy. Then upper limit of x is a by root 2, and y lower limit is x is equal to 0, that is 0 to 1. Sine inverse of x is a by root 2, a by root 2 upon a, upper limit minus lower limit, sine inverse x value is 0, 0 upon 0, 0 upon a is 0 dx, 0 to 1, sine inverse of a by root 2 upon a, that means a cancel, 1 by root 2 minus sine inverse 0 dx. Now sine inverse 1 by root 2, because sine pi by 4 is 1 by root 2, therefore sine inverse 1 by root 2 is pi by 4, and sine inverse 0, for second formula sine 0 is 0, therefore sine inverse 0 is also 0. Now values 0 to 1, sine inverse 1 by root 2 means pi by 4, pi by 4 minus 0, that is only pi by 4 dx, pi by 4 constant, integration 0 to 1 dx, that is pi by 4, integration of dx is x, 0 to 1, upper limit of x is 1, lower limit is 0, therefore answer is pi by 4. In this example, we have seen here inner limits are functions of y. We first integrate with respect to x.